Good morning. This is a quick overview lecture video for our electrostatics unit, part 1. We'll be talking about electricity, electric force and charge, and conservation of charge. So to start us off, we have electricity. Electricity is a name given to a wide range of electrical phenomena, such as lightning, a spark when we strike a match, what holds atoms together. Electrostatics involves electric charges, the forces between them, the aura that surrounds them, and their behavior in materials. So this section is focused mostly on electrostatics. Electricity will be coming along a little bit later. Electric forces and charges. Central role of electricity is opposites charges attract one another like charges repel. So you've most likely heard the term opposites attract, but maybe not in the context of physics. And that is what we're studying. So in physics and actually chemistry too. Opposites attract, sames repel. So if we look at these three images, we can see that these are essentially little lightweight balls that are coated in a conductive material, and a positive charge has been placed on these two and a negative charge on these two, and then opposites on these. You can see that here the minus and plus are going towards each other. They're not hanging straight down. They're not hanging away from each other, but they're hanging towards each other. And in the first two pictures, we see that they're being pushed away. So this is a lightweight string, and this shows that they're being pushed from each other because they're not hanging straight down anymore. So you're going to answer 4 questions that go with this slide. Electric force and charges continued. All right, this is the general structure of an atom. You have your protons and neutrons in the center here, and then on the outside you have your electrons. I used the analogy yesterday of an arm. So your arm, the bone, would be the center part of the atom, and all the flesh would be the electron cloud. Now, this is showing a helium atom because there are only 2 electrons and 2 protons. We're talking about atoms and electrons on a much larger scale, but for the sake of simplicity, this drawing is just showing 2 of each. So a very small atom. Now, for when you move charges, you're always moving the outside electrons. Because, for example, like if I have my arm and the bone is the proton or the positively charged, all the flesh from the bone to the outside is your electrons. So if I scratch my arm, I'm going to get skin, which are the electrons, well before I'm going to get protons. So the protons don't move, only the electrons. Now, in a neutral atom, the electrons equal the protons. So you can see in this picture, there are 2 electrons, 1, 2, and 2 protons, 1, 2. So this is essentially, if I do 2 negative, okay, and then I add to that 2 positive, then the sum would be 0. Okay, so if I gave you 2 and then took away 2, that's 0. And so in this particular picture, this represents an atom that has a 0 charge because it has 2 electrons and 2 protons, which cancels out. Now, if I add an extra electron, okay, then I would have 3 electrons and 2 protons. So if I have -3 and +2, then I have a -1 as my sum. So if I have extra electrons, I'm going to have a negative charge because electrons are negative. Now, if I take away electrons, so let me go ahead and erase this just so we can see this better here. Okay, so if I delete an electron, okay, so if I take away an electron, remove it, and just take it away and move it over here or something, it gets scraped off in the process of static charging, friction, something like that. Then we have 2 protons, okay, and only 1 electron. which means that the sum will be +1. So this atom would be an ion, and it would have a charge of +1. So this electron over here is being canceled out by one of the protons, but the other proton's not being canceled out because that electron was removed. So the leftover charge is just +1 because you have one proton that's not being canceled out anymore. So now this atom is an ion and it is positive. So the only way you can create a positive charge is to remove electrons. The only way to create a negative charge is to add electrons. Okie doke. Fundamental facts about atoms. Every atom is composed of a positively charged nucleus surrounded by negatively charged electrons. Each of the electrons in an atom has the same quantity of negative charge and same mass. Protons and neutrons compose the nucleus. Protons, and it just gives you size references. And then protons, neutrons have no charge. The question that goes with that is over here. It says, which particle in an atom has the equal amount of charge as an electron, but the opposite sign? Atoms usually have as many electrons as protons, so the atom has a 0 net charge, which I just showed you above, how if you take the total number of protons, total number of electrons, if they're the same, then the answer is 0. So it says when the number of electrons in an atom equal the number of electrons, what is the atom's net charge? The net charge of an atom equals the number of protons in the nucleus, the number of electrons surrounding the nucleus, 0 if the atom is electrically neutral, always 0. If a neutral atom has 22 protons in the nucleus, so positive charges, the number of surrounding electrons is less than 22, 22, more than 22. Sometimes any of these in a neutral atom. Read carefully, make sure you're applying the concept I showed you above of if you take the total positive, the total negative, add it together, and the sum is the charge on the atom. Electric force and charge continued. So here we have the description of a positive and negative ion. So positive ion is an atom that has lost more than one or more electrons, which means that you now have a proton that doesn't have a pair to cancel it out. Negative ion, you have an atom that has gained an electron or one or more electrons. A negative ion has more electrons than neutrons, electrons than protons, protons than electrons, neutrons than protons plus electrons. So to address this, what I would do is just kind of look at them, what charges things have. So electrons are negative, neutrons are 0, electrons are negative, protons are positive, protons are positive, electrons are negative, neutrons are 0, protons are positive, and electrons are negative. So a negative ion has more negative than it has positive. So which of these descriptions explains that? Electrons in an atom. Innermost electrons are attracted very strongly to the nucleus. The outermost are loosely and can be easily dislodged. So remember the analogy of the arm. So the innermost electrons are the ones like the muscle and whatever of your arm, and then the outermost electrons are like your skin. So if I'm going to just do that, I'm only going to get skin. I'm going to get the electrons on the outside. All right. When we charge something like static, like we rub a balloon on our hair or we comb our hair and result in some sort of charge being formed, we get that, like if you've ever brushed your hair and it like goes all crackly. What's happening is you're removing electrons from your hair in this case. So your hair becomes positive, the comb becomes negative. A common experiment, which we'll talk about later, is if you take a glass piece of glass rod and you rub silk against it, the electrons transfer from the rod to the silk and the rod becomes positive. So wherever the electrons are leaving, it becomes positive, and wherever the electrons are going becomes negative. conservation of charge. In any charging process, no electrons are created or destroyed. They're simply transferred. So this is using a glass rod and fur. And they're showing that the electrons, there's more electrons now on the one. This has a negative charge, which means that, question mark, what would the wool have? Well, it just lost electrons to there, so it now is positive. When we say charge is conserved, we mean that charge can what? Which of the following matches the question?